So, okay. So select an initial number of atoms of each type and analyze what happens as that atom reacts and ions are formed. So this will happen.
Mm-hmm.
Okay, let me draw that.
Not really much else to add to that.
No, it makes sense. Because like now when I go back to the reading, then I'm like, okay, this is what Jim is talking about.
Yeah.
Okay, so the second question says, based on your observations, explain why an ionic network is formed in this case rather than a collection of independent molecules.
Yeah. So the question is, why don't we just have magnesium bonded to oxygen, like that, and like that?
You can erase the other one if you want to. So.
Well,
Okay,
it's
you
a
don't have to.
comparison. So why is it like this instead of like that? And the reason being is because it's to the point where it doesn't share its electrons, it freely gives them away.
So-
Okay? It gives away their electrons, so there's not really any attachment. Okay?
Wait. Sorry, say it again.
So because it gave its electrons away, it doesn't feel as obligated, just to stay solely attached to that one. Yeah.
So in other words, it's because it's easier just to give them away than
It's easier for it to give it away than to share, because it can't form a quadruple bond. It wouldn't be able to do it.
And I don't think you need the other one. The other one, you just need two equivalents of NaH2, because this guy here is not terminal. This only happens to be terminal on alkyne.
Okay, number 3. Analyze what happens to the ionic network as you increase the temperature.
So as you increase the temperature, because these guys are only held together by their, this attraction, what's going to happen as you increase the temperature is that these guys will start to vibrate more and more as they absorb more energy to the point where they'll actually separate. Okay? And so it'll be just, this is like it in solid form, and then we have just ions just floating around in the liquid form. Okay? With some space in between them. Like salt, when you melt it, it looks like water, it looks like a very clear liquid. Okay? That's because all the bonds are disassociated and they're just free flowing. And these guys, it depends.
So with the heat it will vibrate and...
Yeah. But yeah, so these guys will have stronger, or will require more energy to separate them than molecules. Okay? Molecules, even though they have covalent bonds, because they're so small, they don't require as much energy. But because these guys are a big, huge network, you're going to need energy overall to make it.
Molecules are the ones that doesn't have metals.
Yeah.
And all the ones that have metals, like all on this side and the bottom, they're all ionics.
Yes.
Okay. So, what were you saying? The molecules require more energy?
No, molecules require less energy because they're so small. I mean, like something like this, you just need the energy to break that. That's all the energy you need. Here, you need to get all the energy at once to break all these bonds. Okay, so it's obviously going to require a lot more energy to melt this than to melt this, because here you're just breaking one bond. Like I don't know if you remember in the lab that we did at the beginning of the semester, we melted the sugar, and the sugar just melted like that. It became caramel, and then it started burning because those bonds actually started breaking. Whereas here, the salt, we told you that you had to only put a very tiny amount in the bottom of the test tube so that it would melt. Otherwise, it would require a lot more energy to melt all that salt, which you wouldn't be able to get unless you only had a very little amount.
So salt is ionic?
Salt is ionic. Because salt is NaCl. You have a sodium ion, which has 1, and then a Cl atom, this is a sodium atom, and a chlorine atom, which has 7, and then basically this guy just goes right there, and we have sodium plus and Cl minus. Okay, and so there's our ion. This is an ion and that's an ion.
And it takes like a lot more energy to separate because there's like in the here and here, there's everywhere, so you can't just like separate them like one way, it's like everywhere. Okay.
Like this is a big, huge building block. Like I don't know if you ever looked at a salt crystal, but they're actually cubic. Like they're all square and rectangular, and they look like a cube.